Hello guys, welcome you all for this end-to-end session of AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot, and we are learning a lot each and every day. Okay, many new things we are enjoying. Okay, so hope the same thing for you guys. If you guys doesn't subscribe to our channel till this point, please subscribe to our channel because like every day we are just uploading new video. Just subscribe to our channel and press the bell icon so that you can get the notification whenever we are uploading a new video. So yeah, guys, without wasting any time, let us jump into today's session. So as always, please make sure that you guys watch all the previous session videos so that you can understand and able to understand the context of what we are talking. Okay. So today it's a model evaluation in metrics and data science, more specifically clustering and dimensional reduction techniques. Okay, guys. Actually, we have completed unsupervised learning. A part of unsupervised learning, actually, one more thing is bending, that is association rule. We're gonna cover, I think, in the next session we're gonna cover. Okay, so that is what. So today we're gonna see what are the metrics that we are having, because like we have played like nearly 10 plus sessions with dimensional direction as well as with the clustering. So today we're going to see what are the metrics that we are having in order to evaluate the model. Okay, so I think sir in one of the session as explained, right, once we have done with the model, we doesn't know how it works, then there is no point of building a model, right? So we need to find a way how to evaluate the model so that we can say, yeah, the our model which we have built is working fine. So we are having a dedicated session for model evaluation on clustering and dimensionality reduction. Okay, so let us jump into today's session. Okay, so model evaluation metrics in data science. This presentation explores a key evaluation metrics used in data science to access the performance of machine learning models, specifically focusing on clustering and dimensional reduction techniques. Okay, let's start enjoying it. Okay, yeah, sir, over to you.
Yeah, so model evaluation metrics in data science and AIML, guys, we have to understand the the evaluation metrics very deeply so that we can apply them properly. So they they assess the performance of the machine learning model when you do the evaluation properly, specifically focusing on clustering, dimensionality reduction, and other techniques. So we have to go deeply into all the components of model evaluation metrics in data science and AIML. So let's move to the other section.
Yeah, sure, sir. Let's move on. Okay, yeah, clustering evaluation metrics. Okay, let's see the metrics which is related to clustering. Guys, what is clustering? Grouping of data points based on similarity, that is called as clustering, right? Let's see what are the metrics that we are having for clustering. Internal metrics, these metrics evaluate the quality of cluster based on the internal structure of data. Okay, how the data looks, based on that it is going to evaluate by using the internal structure. Sorry. Next we are having external structure. These metrics compares the cluster's result to a known ground truth or an external reference. Yeah, we are having multiple clusters, right? How it gonna evaluate means we're gonna have multiple clusters. Based on those clusters, it is gonna evaluate. Internal metrics means within cluster evaluation, whereas external clusters mean between cluster evaluation. Next, we are having relative metrics, where these metrics compare the performance of different clustering algorithms or parameter settings. Yeah, relative metrics means we are having multiple clustering techniques, right? Hierarchical clustering, we are having something called as k-means clustering, spectral clustering, different clustering. So what are the accuracy of those clustering? That is called as relative metrics. Or we are having k-means clustering and we are having different hyperparameters, right? By tuning those hyperparameters, what are the different accuracy that we are getting? That is also called as a relative metrics. Okay. Now, next we are having visual inspection. So visualizing the cluster can provide valuable insights into the effectiveness of the clustering algorithm. Yeah, I think last session we have seen TSNE, right? The coding part. Simple visualization, right? Using that also we can evaluate this clustering technique. Okay. Hope you guys can able to understand. So we are having different kind of metrics in order to evaluate the clustering algorithm, like internal metrics, external metrics, relative metrics, and then visual inspection. Okay. So hope it is understandable. If you guys doesn't understand, please ping us in the comment section. We'll take them and we'll solve your doubts. Okay. So yeah, so over to you.
So clustering evaluation matrix, we have four components. One is internal matrix. Okay, these matrix evaluate the quality of clustering based on the internal structure of the data. That is why it is called internal metrics. So then we have external metrics. The metrics compares to clustering result known as ground truth for external reference. Okay, that is why the name is external metrics. Relative metrics, which is the metrics compared to the performance of different clusters, algorithms, or parameter setting. So we do relative study and all, okay, comparison. So visual inspection, visualizing the cluster can provide valuable insights into effectiveness of the clustering algorithm. So clustering evaluation metrics have these four components, characteristics. So learn deeply, guys, with long-term objective function with patience, persistency, consistency, and perseverance, and understand these concepts deeply so that meta level, so that you can apply them properly and do all the assignments and quizzes, and write to the comment section if you have any question. We'll be helping you out.
Yeah, guys, let's move on to the next slide. Okay. Yeah. First is silver score. I hope, like, guys, if you guys watched our all videos, I hope like this is going to be the combination of evaluation metrics in order to understand the clustering and dimensional integration. If you guys watched all our videos related to clustering and dimensional integration, then it's going to be very easier for you. Okay. Let's see how the silver score works for the clustering technique. Definition: a silver score measures how similar a data point is to its own cluster compared to the other cluster. A data point is in cluster A, how it is similar to all other data points in cluster A, and how it differs from other data points in other clusters. That is what silver score. Range. The score ranges from -1 to 1, where 1 identifies perfect cluster and 0 indicates a overlapping cluster. Okay. So silver score ranges from -1 to 1. 1, we need to get 1 of a data point which gets a silver score 1. Yeah, that's a perfect thing that belongs to that cluster. Okay. Next, interpretations. A high silver score suggests that the data points are well clustered and separated. Okay, so we need to have a value of 1, so then only we can call it as, yeah, this data point, yeah, truly belongs to the cluster. Okay, so yeah, this is what about silver score. I hope like simple explanation, right? So yeah, sir, over to you.
Yeah. So silver score, the what is it definition? Let's go to the definition. The silver score measures how similar a data point is to its own cluster. Okay, so how similar data point is to its own cluster. So it should be very good similar. So the similarity of the more data points in the cluster, its own cluster, the more the silver score compared to the other clusters. So that's the first thing, okay? First element and characteristics of the silver score. So then we have range. The score ranges from 1 to 1, where 1 indicates perfect clustering and 0 indicates overlapping with the cluster. So there shouldn't be overlapping, okay? That's what range means. So interpretation, like interpretation is high silver score suggests that the data points are well clustered and separated. So that is these are three elements which completely define silhouette score. So first is the definition, where the similarity of data points should be in the own data compared to other clusters, and then range is from 1 to 0. 1 and 1 to 1 is where the perfect clustering, and 0 indicates overlapping. So range should be clear, like range defines these things. And then interpretation, where it suggests that the data points are well clustered and separated. So that is that is the main thing. And then these are the three elements which define the silver score properly. Let's move to the other section.
Sure, sir. Yeah. Next, we will say Kyleson index. Okay, how it works. Okay, similar to silver score. Let's see Kyleson index. So, what is the formula? This index calculate by dividing the between cluster variance by the between cluster variance. Okay, simple. Okay, what is mean by between cluster variance? Between two cluster, what is the distance? within cluster variance, within the cluster, what is the distance? So that is what, how it is calculated, the Kylinson index. We are dividing the between cluster variance, two different clusters divided by within cluster variance in a single cluster. That's it. How we can interpret? Yeah, high index value indicates better separation between the clusters and more compact clusters. Okay, so we need to have high index value such that the two clusters are well and very much separated, and also the data points which is within the cluster is as the more compactness. Okay, next, what is the advantage? It is simple to calculate and provide a good overall measure of clustering quality. Okay, when compared to the Silbert score, this Kylinson index is somewhat advanced thing, because like it gonna consider both the between cluster variance as well as within cluster variance. Okay, so yeah, this is one more thing that we are having for clustering evaluation. So yeah, so over to you.
Yeah, Chelsky, again, this is the index which is very helpful for like clustering variance. It helps us cluster variance. Okay, what is the variance between clusters and all? So the formula is index is calculated by the dividing between cluster variance by within the cluster variance. So that is the formula, and interpretation is high index value indicates better separation between clusters and more compared clusters. So that is the thing, that it should be well separated. So advantage, it is simply to calculate and provide a good overall measure of clustering quality. So these are the components for Chalesky, this index. So we use it for kind of understanding that if the clusters have variance, so we check that we calculate dividing between cluster variance and within the cluster variance. So we go to knowledge of knowledge. So we try to go to a ontological level, so meta level, to understand the variance, and then interpretation is to like it should be betterly separated and more compact clusters. Like there should be a separation, and then it is very simple. That is the advantage. So these are the components for this technique. So let's move to the other section.
Yeah, sure, sir. Let's move on to the next thing. Okay. Okay. Next, we are having a Dale's index. Okay, Dale's. So Dale's index. Okay, Davies index. Okay. So how it is differ? Okay, let's see. It is also used to measure the within cluster distance. There is variance, right? In the previous metrics, we have seen variance, but in this index, we have seen within cluster distance and between cluster distance. Within cluster distance means average distance between the data points within the same cluster. Between cluster distance means between the distance between clusters of different centroids. That is what this index. This index aims to minimize the ratio of within cluster distance to the between cluster distance. Okay, so this is one of the way of we can evaluate the cluster. Okay, so Davies index. So this is how we can evaluate by using the between cluster distance and between cluster distance. Okay, this is one of the way for evaluating the clustering technique. So yes, over to you.
So Davis index is again measures the within cluster distance. That is the main characteristics, and then description is like average distance between data points within the same cluster. It's like main focus here is previously it was the variance. Previous challenge key index, there was a variance it measures that, but here it measures the distance, and then between clusters. Okay, distance, what is the distance, and distance between clusters, centroid, from the centroid, what is the distance. So it's more about, it measures the distance. Okay, the index aims to maximize ratio within cluster distance to between cluster distance. So it's like within cluster distance to between cluster distance. So it is going to see how much is the distance, is it properly distance, so that the cluster, so that there is no overlapping, guys. So actually then the model will learn properly if there's a good separability in the clusters. So separation is there, and it is going to measure the distance, okay, from the centroid and cluster between the clusters. So that's kind of behavior of this particular technique is, and it is created for such aim, objective function. So let's move to the other section.
Yeah, sure, sir. So, guys, we will pass here. So, we have introduced the evaluation metrics for this clustering technique. So, we will pass here and we will continue in the next session. Hope you guys have enjoyed the session. If you guys have any doubt, just ping in the comment section. We will take up and we will solve your doubts. Okay. So, yeah, guys, thank you. Thank you so much for attending this session. Hope you guys have enjoyed. So, please subscribe to our channel if you guys doesn't subscribe to our channel, because like every day we're going to upload a new video. So, subscribe and also notify. And like press the notification icon so that you can get the notification whenever we upload the new videos. Okay. So until next session, bye guys. Take care. We will all meet in the next session. Bye guys.